Robert Naeye. You know that he is an expert in space science. He spent 30 years plus working on magazines such as Discover, Astronomy, and Sky and Telescope. And he's also, as his t-shirt indicates, was a former NASA employee.
Yeah.
So we're glad to have him here today to talk to us about the solar system in which we live. So as I'm getting chairs, he's going to begin, and I hope we don't disturb you too much with noise.
Okay, I guess we're ready to rock and roll here. Okay, well, first of all, I want to thank all of you for coming today. I know it's a pretty nice day out. It's not as hot as it used to be like a couple weeks ago, so I appreciate you spending part of your day with me and the library. I want to thank Melinda, who is very gracious in inviting me and helping me get everything set up. I want to thank this beautiful, beautiful library. I always enjoy coming here. And as I said, I want to thank all of you for coming. So I'm going to talk today about the solar system. And where's my clicker? Oh, I'm holding it in my hand. Okay, so I want to situate us where we're located. We're located in this enormous congregation of stars called the Milky Way Galaxy. And this ring here, this is an artist rendition of what our galaxy would look like if we were looking at it face on. If we were looking at it edge on, it would be like looking at a frisbee. It'd be very thin. So this is face on, where you can see the spiral arms. Here's the center of the galaxy. There's a big black hole in the middle. That's in the constellation Sagittarius. And we're about halfway out from the center to the visible edge of the disk. Now in reality, you see the circle where the solar system is. In reality, on the scale of this map, our solar system would be so tiny you wouldn't see it. It's like an infinitesimal portion of our galaxy. The galaxy has about 200 billion stars. From end to end, it's about 100,000 light years across. That's 600, let's see, billion, whatever. As I said, we're about halfway from the center to the edge. And if you're curious, is the solar system orbits the center at about 514,000 miles an hour, but the galaxy is so enormous that it takes 225 million years to complete an orbit. So the last time we were here was before the age of the dinosaurs, and we've completed about 20 galactic orbits since the solar system formed. So I just want to give you that to situate where we are. Now this is a very beautifully done illustration of the solar system, but nothing in this illustration is to scale. But you can see we have 4 inner planets: Mercury, Venus, Earth, Mars, the asteroid belt. Then we've got Jupiter and Saturn, the gas giants. Then Uranus and Neptune, which are smaller. And then we've got all these objects out here. We also have comets. But the next slide shows what the solar system is really like.
Yeah.
Okay. The solar system is almost entirely, like way more than 99.9% of its volume is essentially empty space. So I want you to keep that in mind throughout the rest of the talk. The solar system is mostly empty space, by far. Now this is a much more accurate scale diagram. It's really hard to do a scale diagram of the solar system because the distances are so vast. In this map, the distances are rendered pretty accurately. The planet sizes really aren't rendered particularly accurately, nor are their sizes relative to the distance to the sun. You can't do a true scale diagram of the solar system. Now, I'm going to be talking today about what's called an astronomical unit, or AU. Okay, that is the average Earth-Sun distance, and that is 93 million miles. That means it takes light from the sun 8 minutes, 20 seconds to get here. So if the sun suddenly vanished, we'd have 8 minutes and 20 seconds to live before the Earth froze. And if you're curious, you could actually do this in a lifetime if you're willing to make 19,000 round-trip flights between New York to LA to New York. It would take 51, I calculated this, it would take 51 years to do that round trip every day. That would get you the distance to the sun. So that's actually something you could do if you wanted to. I don't recommend it, but you could if you wanted to. You could fly the distance on Earth without leaving Earth. You could fly the distance to the sun, but it would take you a long time. So this is a diagram of the solar system. And one thing, and astronomers knew this, hundreds of years ago, is that all the planets orbit the sun in more or less the same plane. There are a couple of them, like Earth, are tipped a little bit, but they more or less are in a flat plane. Now Pluto, as you can see here, is highly tipped, about 17 degrees. All the planets too, their orbits are not perfect circles, but they're close. They have what's called a low eccentricity, meaning they're oval, their orbits are oval, but very close to being a circle, except for Pluto, which has a highly elliptical orbit or eccentric orbit. So the planets formed in a big cloud of gas. This is one of the nearest ones to Earth. You can see this with the naked eye in the constellation Orion, called the Orion Nebula. And this is basically a giant cloud of gas and dust, several dozen light years across, and young stars are forming from the gas inside this nebula. And here's a really nice illustration of how this happens. Is you have a big cloud of gas and dust, it starts to spin, and gravity is pulling it inward, and eventually inside the cloud, and you might get hundreds or thousands of planetary systems and stars, you get a disk around which you have the star in the middle, and the planets then, this whole disk is spinning, and you end up with a star with planets orbiting around it. The nice thing is that explains why all the planets are in the same plane that I showed you a minute ago. And so you're wondering, that this theory actually dates back to the 1700s, and you might be wondering, how good is this theory? And the general picture is spectacularly good. So this is an artist rendition of what the early solar system would have looked like as the planets are forming. You have a disk, most of the material ends up in the sun, and you have a lot of rocky material, debris basically, and gas left over in the disk. And that's where the planets form. And this is an amazing image. This is a visible light image of a young star forming region. And there's this network of microwave telescopes that see in microwave light in Chile called the ALMA Observatory. And they took this incredibly high resolution image in microwaves of a disk around the young star. And just go back a second. This predates this image. Pretty good. Yeah. In fact, they think, I'm sure that this is right, there are planets forming inside this disk where we see the gaps, these darker regions. So almost all the material from that initial collapsing cloud ended up in the sun. So the sun contains almost the entire mass of the solar system. In other words, all the material in the solar system is in the sun. So if you're the sun and you're not being charitable on a particular day, you would say the solar system is me and everything else is just leftover debris. If you're the sun and you're charitable, and you're really being nice that day, you would say, okay, the solar system is the sun, Jupiter, and everything else is debris. If you're being nice that day. Okay, so you could fit 1.3 million Earths inside the sun, and the sun contains about 333,000 times the mass of the Earth. So it's an enormous, absolutely enormous ball, mostly of hydrogen and helium gas at very, very high temperature. It's actually what's called a plasma. So there's an artist who lives in the Lehigh Valley here in Pennsylvania named James Paley, who has created these wonderful cartoons. So I'm going to be using these cartoons throughout the talk. All the cartoons are his. If you're curious, we're going around the sun at 18.5 miles a second. That's 66,000 miles an hour. So every day you travel about 1.6 million miles around the sun. So we are space travelers. And remember, the solar system is orbiting at an even higher speed around the center of the galaxy. So we are at every moment, we're moving at very high speed in outer space. Now, if you're wondering, is the sun a big star or a little star? It's kind of both. And I'm going to liken it in that regard, the sun is like Harrisburg. Okay, if you take all the cities in the United States, you got New York, LA, Chicago, that are way bigger than Harrisburg. Okay, but if you look at like communities all across the United States, Harrisburg is much bigger than your typical community. I mean, I live in Hershey, which is, fairly sizable, but Harrisburg's got like twice the population of Derry Township. You've got tiny little towns with like dozens or just a few hundred people. It's like that with stars. So here's the sun compared to two of its neighbors, Proxima Centauri and Sirius B. Compared to those stars, the sun's pretty big. And the sun is like bigger than like, what is it, Lou, about 80% of the stars in the galaxy. Okay, but then you have stars like, here's the sun. You've got stars like Procyon, Arcturus, Rigel, Antares, and UY Scuti. These stars are these are like Los Angeles and New York and Tokyo, etc. So you got stars that are way bigger than the sun, but they're pretty rare. Most of the stars in the galaxy are actually smaller than the sun, but the sun's kind of in between. So the sun, here's a nice diagram of its internal structure. The real action is taking place in the core, and then what we see is this outer layer called the photosphere. And at the center of the sun, the temperature is 27 million degrees Fahrenheit, and it is like under incredibly high pressure because you have all this mass pushing down against the core. And when you get those pressure and temperature, something really magical happens. You get what's called thermonuclear fusion, where you can get isotopes of hydrogen, deuterium and tritium, that are going to stick together. They're moving around at high speed at the center of the center. They stick together to form a helium nucleus, and that process gives off energy. And that's the energy that eventually makes its way out of the sun and bathes the solar system in light. So this all comes from the center of the sun. And this is the most technical term I'm going to use today. The sun is in what's called hydrostatic equilibrium. And what that means is there's gravity that's trying to pull the sun inward and compress it into a black hole. But then you have the radiation pressure, this energy coming out from the sun. And the two of them balance each other out. So the sun is in this state of equilibrium. Now, over time, though, the sun is gradually getting warmer. So the sun is actually about 30% more luminous, putting out more energy today than it was 4.5 billion years ago when the solar system formed. That's going to have ramifications that I'll talk about later. Okay, and the sun is a little less than halfway through its life cycle. It's gradually getting warmer, and by the way, this is not what is causing the current warming we see here on Earth. That is from anthropogenic emissions and activity. From year to year, this warming of the sun is immeasurable. It's something that you could only measure over millions of years. The sun is eventually going to expand into a red giant. When it does so, it's going to engulf Mercury and Venus. They're gone. They're going to disappear. The Earth is just far enough out that the sun is going to eject its outer layers, forming what's called a planetary nebula, loses mass, so Earth's orbit will expand. And the latest calculations, I think, are almost certainly right, is the Earth will survive. And one final thing before I move to the planets is the sun is constantly ejecting charged particles, things like protons and electrons. This is a major storm called a coronal mass ejection, but it also this would be more like the steady stream called the solar wind, and the velocity averages about 1,000,000 miles an hour, but these are subatomic particles. But remember, the solar wind is constantly buffeting the planets and is trying to strip their atmospheres away. So the sun in that sense is not very nice. Now time to get to the planets. This is a scale model of, I love these models, of the 8 planets that are now considered planets: Jupiter, Saturn, Uranus, Neptune, Earth, Venus, Mars, and Mercury, so you get a good idea of their relative sizes. And one thing, astronomers realized this centuries ago, the 4 inner planets have what's very high density, which tells you they're made mostly of rocky and material and metals. So this is the density in grams per cubic centimeter. Liquid water is 1. So you can see Earth is actually the most dense planet in the solar system, but very similar to Mercury and Venus. Mars is still a little under 4, but look what happens when we get to the outer solar system. The density goes way, way down. So these are giant planets, but they have low densities, which tell you they're mostly made of liquid and gas. So we have a clear demarcation in the solar system that I'll be discussing. Okay, so I want to start off, I'm going to go close to the sun and then outward. And by the way, halfway through, after the asteroid belt, I'll take a couple questions. So here's a nice photo. This is a mosaic from NASA's Messenger spacecraft showing Mercury, which has a very heavily cratered surface, which tells you that it's been battered for billions of years by asteroids and comets. And Mercury doesn't have things like wind and water erosion. It doesn't have, plate tectonics or an atmosphere to erase the craters. So this is an ancient surface of Mercury. So not much has happened on Mercury for a very long time. Now this is a really cool picture of Mercury is in this picture. It's right here, this dot. So you can see how small Mercury is relative to the sun. This is what's called a Mercury transit, where Mercury, as seen from Earth, over a few hours crosses the disk of the sun. Now the thing that's interesting is this picture makes Mercury look bigger than it really is relative to the sun, because it's closer to the Earth than the sun is in this picture. So this gives you an idea of how small Mercury is. And here we see Mercury compared to Earth. It's about maybe 1/3 the diameter of Earth. And you can see it's only about a little under 6% the mass of Earth. Mercury is mostly it's mostly nickel and iron, and it has a very thin, and when we get to Earth, remember what this diagram, it's mostly core, and the core is very heavy material, like nickel and iron and metals, and it has a thin mantle and a very thin crust. The current thinking is that early in its history, Mercury got hit by a pretty large object, kind of a little bit smaller planet, and it stripped it of most of its mantle and crust. So Mercury is kind of what's left over of what was probably, when it formed, a bigger planet. Now Mercury is so close to the sun, and its mass is so low, that literally cannot hang on to an atmosphere. Remember I mentioned earlier the solar wind? The solar wind is going to, anytime, if Mercury tried to form an atmosphere, the solar wind would just blow it away. Another thing is Mercury cannot hang on to a moon. It could have a temporary moon, but due to its gravitational interactions with the sun, eventually its moon would get stripped away. So Mercury does not have a moon, and it might have a temporary moon from time to time, but it can never have a permanent moon. Same with Venus, by the way. One other amazing fact about Mercury is Mercury's so close to the sun that its axial tilt is almost exactly perpendicular to the plane of its orbit. Okay, that means that there's craters at the northern and southern hemisphere that are shielded from sunlight. For billions of years, they've never gotten any sunlight. They are the coldest places in the solar system, even though the planet is really close to the sun. Like the part of Mercury that faces the sun is like 450 degrees Fahrenheit. These are close to absolute zero. So there could be, in fact, there is water, frozen water ice, in these craters at the north and south pole of Mercury. I find that pretty amazing. Okay, next planet out is Venus. This is a near true color picture from the European Space Agency's Venus Express orbiter, which orbited Venus, I think it was about 10 years ago. It's a little bit color enhanced, so you see some cloud structure, but one thing you'll notice immediately, you can't see anything on the surface. This is a planet enveloped in thick clouds. And another strange fact about Venus is that it rotates the wrong way. It's the only planet in the solar system that rotates in the opposite direction in which it revolves around the sun. So all the planets go around the sun in the same direction, but they all also rotate in that direction, except I'll mention one other exception later. But Venus rotates the wrong way. So in other words, the sun would rise in the west and set in the east, although you'd never see the sun because of the thick clouds. So it's that's very weird. The best theory I'm aware of is it got hit with a large object very early in its history during that planetesimal era, and that reversed its spin. But I find that really amazing that it rotates the wrong way. If you could strip away the clouds and see the surface, this is what it would look like. This is from radar data from a NASA spacecraft that orbited Venus a number of years ago called Magellan. And the thing is, Venus's surface is really different from Earth. There's no like continents. The mountains aren't super high. It's a little bit flatter. There's not a lot of craters. They've mainly been erased. But it has a very different kind of surface than Earth. But what's weird is the two planets are very similar in size. So, I mean, there's no other object even close. Everything else in the solar system's either a lot bigger than Earth or a lot smaller than Earth. But you can see, in terms of size and mass, Venus is pretty much Earth's twin. So astronomers, and this shows how naive they were, used to think that Venus was like a primitive version of Earth, and it had things like dinosaurs on the surface. So this was an actual display in New York back in 1950. Okay, this is about as wrong as you can get. Okay, this is what Venus's surface actually looks like. This is from a Soviet Venera lander from 1982. Now, the Soviets successfully landed 4 spacecraft on Venus. That is an absolutely tremendous technological achievement. And I can tell you how amazing that is. NASA's never even tried. Okay, the problem is that atmosphere exerts such pressure that the pressure at the surface is about 100 times the pressure versus atmosphere at the surface, so it would crush you. Like within a second, you'd be dead from the pressure alone. It's like being like quite, I don't know exactly, do you know, Lou, how deep underwater you'd have to be? Pretty deep. The other problem is that it's a very thick greenhouse atmosphere that is mostly carbon dioxide. Now, what's carbon dioxide? Greenhouse gas. Yep. This is a much thicker atmosphere than Earth with a lot of carbon dioxide. So the temperature at the surface, even on the night side, is like 800 to 900 degrees Fahrenheit. That's hotter than your oven. So this is the hottest place in the solar system other than the sun itself. So all 4 of their landers, and once again, we have pictures from 4 different spots on Venus. They all kind of look like this. Their landers only survive for about an hour before they succumb to these devastating conditions. Now, when I worked at NASA Goddard Space Flight Center, there was a team that was designing a lander. They never got funded, that they claimed could have lasted about a month. Okay, but like I don't think we're ever going to have people living on Venus. Not an easy place. You'd have to like strip most of its atmosphere first. So I like this illustration of Venus. I won't lie, I really do want to kill you. So as I said, this is what the problem is. You have this, Venus is close to the sun. The sunlight comes in, hits the surface, and the atmosphere just traps it. So this is a greenhouse effect gone berserk. And I like this cartoon. Another beautiful day for exploring the planet Venus, when the surface is kind of reminiscent of hell. Now, a couple years ago, an international team of astronomers, some of whom I know, made headlines by claiming that they detected with radio telescopes radio waves emitted from the atmosphere, kind of upper in the atmosphere, where conditions are more conducive to like terrestrial life, of a molecule called phosphine. Okay, now on Earth, there is a tiny trace amount of phosphine in Earth's atmosphere, and it is all biologically produced from like cyanobacteria, or various types of microbial bacteria. So they're saying maybe there could be life in the clouds of Venus. Well, the detection is under debate. Not all astronomers are convinced. And even if they're right, there could be some chemical process in the clouds of Venus that are producing phosphine that we don't have here on Earth. So I would say this is an intriguing discovery. It merits serious consideration, but I would argue we have not yet proven that there's life in the atmosphere of Venus. I'm not saying it's disproven though either. Okay, so now we come to our, or at least my favorite planet. I assume it's all of your favorite planet. And of course, we're 1 AU from the sun, because that's how we define an AU. And I think all of you know what our year is. And this is a beautiful satellite image. I can't remember which satellite took this picture, but it's a spectacular picture. And as Carl Sagan would say, everyone you ever heard of, every human being who ever lived, including Carl Sagan, lived out their lives right here. Little blue oasis in the vastness of space. And here's the Earth's internal structure. And what's really interesting is we have this core. The inner core is mostly solid now, but the outer core is still liquid. That's all heat left over from the planet's formation that keeps that core in a liquid state. Okay, well, you all know the Earth is rotating. We rotate every 24 hours. And that rotation with the combined magnetically conducting material in the core, that creates like a dynamo effect, and it gives Earth a magnetic field. And we actually have a pretty impressive magnetic field. It's not, we'll see Jupiter, for example, is much more powerful, but it's a very serious magnetic field. The Earth has undoubtedly had it for its entire history, and that magnetic field takes a lot of these particles in the solar wind and deflects them and prevents them from slamming into Earth's atmosphere. So Earth has been able to hang on to, a fairly sizable atmosphere for its entire existence. And the particles from the sun that do hit the Earth, that get deflected by the magnetic field into the polar regions, that's what gives us the aurora borealis, and in the southern hemisphere, the aurora australis. Okay, another interesting thing about Earth is that its surface, its crust, is broken up kind of like a cracked eggshell, forming our tectonic plates. Okay, you can see the motions of the plates here. Remember last week we had a big earthquake right off the coast of the Kamchatka Peninsula. Most of the volcanic and earthquakes happen along these plate boundaries. I heard there was a little earthquake just last night, like where was it, New York or New Jersey? We're in the middle of a plate, so like in this area we tend to get very weak earthquakes. But most of the really big, powerful quakes are along these plate boundaries. And that's all driven in the mantle of the Earth, which is partially molten, and you get convection where like the warmer material rises, the cooler material sinks, and that kind of creates like a conveyor belt-like effect. And that's what drives the plates along the surface. As far as we know, this is the only world, planet or moon in the solar system where this process occurs. It's probably essential to life on Earth. And you can see that over time, Earth's surface changes due to this plate motion. And if you could go back 225 million years ago, that's when we were last time we were right here in the galaxy, all the continents were more or less together in a supercontinent called Pangaea. And Earth's atmospheric climate, composition, climate, and surface conditions have changed radically over the planet's history. But despite all of these changes, Earth has managed to hold on to an atmosphere and sustain liquid water on its surface. And that's why we have this thriving planet with life, thriving and teeming with life, which make there could be life in other places in the solar system, but probably nowhere even remotely comparable to the complexity and diversity that we have on Earth. And if you're interested in the history of Earth, I have 2 YouTube videos of a talk, part 1 and part 2. I was literally standing right here, and it was a couple months ago right here at the Frederickson Library. I'm also going to give that talk on November 1st at the Hershey Public Library. Okay, I mentioned the sun is gradually getting hotter. Eventually it's going to boil off the oceans, and the water vapor is a greenhouse gas. So the Earth basically becomes Venus. Not good. And then eventually the sun will expand into a red giant, engulf Mercury and Venus. That's what Earth's going to look like as the sun's a red giant. Now I want to talk about the moon. The first thing that stands out about our moon, even though it's much smaller than Earth, is that it's a really big moon. Okay, relative to the planet, this is the biggest moon in the solar system, relative to the size of its home planet. So it's anomalously big. You can see its diameter is about a little more than a quarter that of Earth, but its mass, it's made of lighter weight material, so it's only about 1% the mass of Earth. And if you're interested, it's about 239,000 miles. That's about 48 New York, LA, New York round trips. So if you did one a day, you could fly the distance to the moon in a month and a half. Okay, so the moon really isn't that far away. It's about 30 Earth diameters. Light from Earth to the moon is 1.3 seconds. So when an Apollo astronaut on the moon said something, we heard it on Earth 1.3 seconds later. Now, some people have said that because the moon is an appreciable size of Earth, that we're really a double planet, but I disagree, because the center of mass, the moon technically doesn't revolve around the Earth. The Earth and the moon revolve around a center of gravity, but that center of gravity is inside the Earth. It's not at the center of Earth, but it's in the mantle of Earth. So to me, we're a planet, that's a moon. It's not a double planet. Do you agree, Lou?
Agreed. And we wobble every month.
That's right, we wobble a little bit because of that effect. But I think because the center of mass is inside the Earth, we are not a double planet.
1%.
So this is the near side of the moon. It's heavily cratered. These are called maria. This is from vast lava outpourings billions of years ago. What's really weird is that's the far side of the moon, more heavily cratered, so it's an older surface. This came as a surprise to astronomers when the first images came back in 1959 from a Soviet Luna orbiter. Like, they expected the far side to be like the near side, but it's not. The exact reason for that is not known. You can really see that afterwards if you check out my planet globe. You can really see how the near side and far side are different. So the moon, for many years, it was a mystery. How did Earth get such a large moon? Well, there was a theory published in the mid-1970s by two different teams of American astronomers. And I have no doubt, there is no doubt in my mind that this theory is correct. I would actually bet my life on it to win $1. Okay? And I wouldn't be worried because I'd win $1 making the bet. Now the details, even to this day, like the details aren't completely agreed upon, but I'm going to just give you quickly the general picture, and I have no doubt this general picture is correct. And that is, very early in Earth's history, Earth got hit at a glancing angle by a Mars-sized planet called, what we now call Theia, and that impact blasted enormous amounts of material into space. Theia was largely destroyed in the impact, and the debris from that impact went into orbit around the Earth, and the debris then, in only about a year, according to the computer simulations, formed the moon. Okay? And the moon at that time was a lot closer to Earth than it is now. It's now slowly spiraling away from Earth because of tidal effects that were first predicted by Charles Darwin's son, George Darwin, in the late 1890s. They've been confirmed by lunar ranging from mirrors left behind by the Apollo astronauts with lasers. So the moon, though, formed much closer to Earth. At the time, a day on Earth would have been 5 hours. That same process that causes the moon to slowly spiral away is lengthening our day. So the Earth originally had a 5-hour day, it's now 24 hours. But this theory explains everything about the Earth-Moon system. It even explains Earth's axial tilt, where we're tilted about 23.5 degrees, our spin axis, relative to the plane in which we orbit the sun. I do hope that in the next few years we see a moon mission. I remember the Apollo missions as a kid. I was too young to remember Mercury and Gemini, but I remember the Apollo 11 landing. I was 6 years old. My mom got me out of bed to watch it. And NASA has a program. Now, I don't know what's happening with the funding. NASA's budget is being absolutely devastated because the current administration doesn't like scientists. But I don't know, they might want to keep the Apollo, this Artemis program, because it's a high profile, but we better get rid of the Canadian astronaut, right? This is the crew that's been training for several years. The plan is for them to orbit the moon multiple times and come back to Earth. And that would then be followed by a lander using SpaceX's Starship lander. The crew has not yet been named, but they would spend 6 days on the moon. You know, this timetable keeps getting pushed back. Depends on funding. So moving out now, we're gonna get to Mars, which is my second favorite planet after Earth. We can see it's about 1.5 times farther from the sun. Its year is about 2 Earth's years. And interestingly, Mars rotates on its axis every 24 hours, 37 minutes. So a day on Mars is almost the same as a day on Earth, a little bit longer. Now, if you're an astronaut living on Mars, you know, the first couple days, you're not gonna really notice it, but over like a couple weeks, it's gonna start being pretty strange. Because your body will get out of sync, but at least for a few days, a day on Mars is gonna seem pretty much like a day on Earth. We can see here is that Mars is about half the diameter of Earth. It's made of a little bit lighter weight material, so it's only about 11% the mass of Earth. The gravity is about 1/3, so take your weight here on Earth, divide it by 3, that's how much you would weigh on Mars. That's one reason I like to go to Mars. One really cool thing about Mars is it's got some really serious features, which you can see on this globe here. It's got the biggest badass I hope the library isn't mad at me for using a swear word, but this is a badass volcano. This whole area covers the size of Arizona. It's called Olympus Mons. And you can see here, this is Mount Everest. Olympus Mons is way bigger. Now Mars doesn't have a sea level. Like on Earth, we say Mount Everest is like, 29,028 feet above sea level. Well, there's no sea level on Mars. So what they do is they take the mean elevation, and on Mars, the summit of Olympus Mons is 72,000 feet above. That's 13.5 miles above the mean elevation. That's like staggering. Mars also has a canyon called Valles Marineris that on the US would go coast to coast, and it's 100 miles wide and 4 miles deep. Now you might be saying, Mars must be a really geologically active planet. In actuality, it's the exact opposite. These features tell us that Mars is basically geologically dead, because on Earth, you would never get a volcano this big. We have plates moving across the surface, so you get a chain of islands, like the Hawaiian Islands. So and the gravity of Earth is higher, so the mountains would sag. We have wind erosion, we have the movement of the plates. These really amazing features are fascinating, but they're actually telling us that Mars is a geologically dead world, or mostly dead. Now this is, my globe here really shows this. This is an elevation map from an altimeter. And by the way, the precision of this map is unbelievable. Every point on Mars, the elevation has been mapped to a precision of 1 meter. Okay, that's like 3 feet.
Yeah.
Now, we don't have that kind of precision on Earth because we don't have the oceans, which are most of Earth's surface, mapped to that precision. So this is like an unbelievable map. And what Mars Global Surveyor is, it's orbiting Mars. It shot a laser down to the surface. Some of that laser light bounced back to the spacecraft. And by timing the time, we know the speed of light. They knew exactly where the spacecraft was. They created this map. And what's really interesting is that the northern hemisphere, look how flat and smooth it is and not many craters. Okay, now if you compare this to ocean basins on Earth, this is what ocean basins on Earth are like. Okay, you can see that in the Earth globe here. Okay, but the southern hemisphere, we've got 2 giant impact basins, very heavily cratered, much higher elevation. Okay, so the northern and southern hemispheres are very different. We're not sure why. This, by the way, is Olympus Mons, that giant volcano. These 3 volcanoes and the ones over here, once again, much bigger than anything on Earth. And here's Valles Marineris. But one thing, just from this map alone, you can see things like that and like that. Now this is not water, but you see what look like channels, like rivers, flowing into this very flat area. So the hypothesis, and I have no doubt this is correct, I don't know if I'd bet my life on it, but I would bet a lot to win $1.
$2.
Yeah, is that this was once an ocean. Okay, now here is high resolution images from 3 different spacecraft showing what do these look like.
Yeah, rivers.
Okay, does it take a genius to see that? And this is interesting. This is an image of the surface from NASA's Pathfinder lander, which landed on July 4th, 1997. The kind of the shape and sizes of these rocks are exactly what you get on Earth in a floodplain. Okay, and then NASA's rover Opportunity discovered all these little sphericals on the surface, and they're the exact size of blueberries. So they're not blue to the eye, but they're called blueberries. Okay, well then Opportunity had an instrument that could smash them and measure their chemical composition. They're rich in an iron oxide called hematite. Well, on Earth, hematite forms like in rivers and lakes in liquid water. So I'm going to say, and I think the overwhelming evidence is that Mars at one time early in its history had liquid water on its surface, and probably it filled up that flat area in the northern hemisphere, and you basically had an ocean roughly the size of the Atlantic Ocean. Okay, and it's funny because NASA every year has some new press release saying NASA's discovered past water on Mars, and they make a big deal of it. Well, this idea dates back to the early and mid 1970s. Okay, the data, even going back from the very first successful NASA missions to Mars, told us that this was what had happened. Okay, so why does Mars not have liquid water on its surface today? That's also a solved mystery. Mars is a small planet. Remember, it's a lot smaller than Earth. Therefore, it has a larger ratio of its surface area relative to the volume. And that means it radiates heat away at a faster rate than a bigger planet like Earth. So it has a core, but the core was at one point it had spinning currents that would create a magnetic field, but the core cooled off and solidified, so Mars lost its magnetic field, and it doesn't have a global magnetic field today. So without the magnetic field to protect its surface, the atmosphere is being slowly blown away by the solar wind and escaping into space. And also, Mars has lower gravity. So Mars has lost its gravity. The pressure at the surface is about 1% the pressure at sea level on Earth. Does have an atmosphere, but it's a very thin atmosphere, not enough to allow liquid water to be stable. Even though it's much colder on Mars, liquid water would evaporate almost instantly because of the extremely low atmospheric pressure. So if there was life on the surface of Mars way back when, it's gone today, and so was the prospects for life. Okay, so I love this cartoon here. I love having oceans, and now poor Mars. I love this guy's cartoons, and here, this one's so clever. You have to remember Paul McCartney yesterday. A day on Mars is called a soul. Yeah, I'm not going to try to sing it because it would vacate the room. But I think that's very clever. So this is Mars' surface today. This was the Viking 1 lander, landed in 1976. And I just want to mention quickly, remember I said the Soviets deserve huge credit for landing on Venus? Well, they tried many times to land on Mars, never successfully. Okay, and one of them, they think it was unlucky that the parachute came down, which was like a 1% probability event. The parachute came down on top of the lander. There was another one that had the bad luck of landing during a global dust storm. So the Soviets, partially their engineering, part of it bad luck. But I can't remember, like NASA's now landed about 10 probes on Mars. All but one of NASA's attempts have been successful. So there's this thing called the Martian Ghoul that like destroys spacecraft going to Mars. Well, NASA actually has a really good track record of landing and putting orbiters in orbit around Mars. I think both of them, the success rate of the NASA missions is well over 90%. In fact, most of these missions have greatly outperformed their design specifications to Congress. For example, you might remember in 2004, NASA landed 2 rovers called Spirit and Opportunity. They were 30-day missions expected to go about 100 yards, football field. Well, Opportunity went for like 20 years and went like 30 miles. Okay, so it vastly outperformed its design characteristics. So NASA has not been victimized by the Martian Ghoul. So the question is there life on Mars today? There may have been in the past. If there is life on Mars, it's probably underground. There are pockets of liquid water underground. There are hydrothermal areas underground. So I am not going to rule out the possibilities there's life on Mars today. There have been whiffs of methane detected in Mars's atmosphere. On Earth, almost all the methane in Earth's atmosphere is biological in origin. Okay, I would just say we don't know. I think it would require human exploration, though. If there is life on Mars today, we're going to need to send people there, and that gets very expensive. Now, Mars also has 2 diminutive moons, and they were discovered at the U.S. Naval Observatory by Asaph Hall in 1877. This is also the grounds where the vice president lives in Washington. And this was probably the first great discovery by an American astronomer. And it was a great discovery because he discovered them at the eyepiece of a telescope. And, you know, I know we got some astronomers here at the Astronomical Society of Harrisburg. You guys have probably seen these moons at a telescope. They are really hard to see. You have to be a really good observer to see these in a telescope. So he discovered them, so he's gone down in history, and deservedly so, for discovering these 2 little moons. Phobos is the bigger moon, it's the inner moon, has a big crater, and that was discovered when, you know, the NASA spacecraft imaged Phobos up close. And they named this crater Stickney, which was the name of Asaph Hall's wife, who encouraged him to keep looking for moons when he wasn't seeing any moons. So I think that's really cool.
That's good.
There's also, and by the way, Phobos is eventually going to crash into Mars, but a long time from now. Deimos is actually moving away from Mars. These are made of different materials than Mars. These are captured asteroids. They're not formed in a collision. They didn't form around Mars. They were asteroids that were very early in the solar system's history, were captured by Mars's gravity. And then speaking of asteroids now, we have the asteroid belt, which is between Mars and Jupiter. And what the asteroid belt is it consists of small, mostly rocky bodies left over from the planet formation era. These are objects that never formed into a planet like Mars or Earth. The total mass of all of these bodies, and there's hundreds of thousands of them, is less than 3% the mass of our moon. So despite the vast number of objects, there's not a lot of material there. This is an illustration of the early solar system. The current theory, and I'm sure this is right, this is one where I think they got it right, is that gravitational perturbations from Jupiter ejected 99.9% of the mass that was originally between Mars and Jupiter. And because so much mass was ejected, that prevented a planet from forming in this region, and Jupiter's gravity probably also prevented Mars from becoming a bigger planet because its gravitational perturbations just ejected so much material. Now, this is the asteroid belt in Star Wars. Okay, really wonderful, like, special effects. But this is what the asteroid belt actually looks like in our solar system. Once again, it's almost entirely empty space. The average distance is about 600,000 miles. That's about 2.5 times the Earth-Moon distance. So let's say you were NASA and you're running NASA and you just want to blindly send spacecraft through the asteroid belt, but you're worried about hitting an asteroid. You would have to send like millions of spacecraft through the asteroid belt before you would randomly hit an asteroid. Okay, that's how small they are relative to the distance between them. So when NASA's spending spacecraft to the outer planets, they're like, people might think, oh my God, is it going to hit an asteroid? It's like, no. I mean, they check to make sure, but no, it's not going to hit an asteroid. The biggest one is called Ceres. It's about 580 miles across. It was discovered on January 1st, 1801, the dawn of the new century, by a Sicilian astronomer named Giuseppe Piazzi. 3 more were found in quick succession. So then they realized this isn't like a planet per se, it's like a belt of what they called minor planets. And in fact, there's some people that say Ceres, you can see it's a sphere, which means it has enough mass that gravity is pulling it into a sphere. So some people think we should call it a dwarf planet, and I think that's very reasonable. By the way, I see Natalia's shirt here. He was an Italian astronomer. And this was a great discovery. This was a great, great discovery. So Piazzi will go down in history for making one of the greatest discoveries of all time. Most of the asteroids, though, except for the largest handful, are in fact, Vesta is like the 4th largest, they're not large enough, so there's enough gravity to pull them into spheres. Okay, so you can see they have kind of these potato and weird shapes. You can see kind of Vesta, which is by far the largest of these 6. It's sort of a sphere, but it's not really a sphere. So most of them are just kind of balls of rock. Some of them, including Ceres, though, have a lot of water ice as well. And before I get to the first Q&A, we have these objects called near-Earth asteroids, and these are objects whose orbits cross the orbits of the 4 inner planets. Now, so we're in a shooting gallery, but this makes the situation look much worse than it actually is, because once again, like, see this orbit here. The object, the asteroid, somewhere on this curve, it's tiny. Earth would be, even tinier on the scale of this illustration. So at any given moment, the odds that any of these objects would hit Earth, incredibly low. But these objects, some of these objects can and do eventually hit Earth and the other inner planets. So the last really big impact was 66 million years ago. It happened at the tip of the Yucatan Peninsula in Mexico, and this caused a mass extinction that destroyed, wiped out almost all marine and animal life on Earth. Only, mostly small creatures survived. There were dinosaurs that survived, by the way. We call them birds. Birds are a branch of the dinosaur family tree. Only a small number of mammals survived. This was a planetary catastrophe. and this was from a near-Earth asteroid that hit 66 million years ago. We get smaller impacts. That's a slimmer me from about 15 years ago.
The universe is expanding.
That's right. Now you can go to right where I'm standing. There's a beautiful. In fact, I once saw it on an airplane flight from Los Angeles to Boston. We flew right over it, and I saw it from the air. A 1 mile wide impact crater in Arizona, northern Arizona, called Meteor Crater. It's near Flagstaff. And this is from an impact from about 50,000 years ago. This was not big enough to have a global impact, but if there had been people living in North America, it would have, the blast wave would have killed everyone within about 1,000 miles. Okay, but it wouldn't have had a global, like here in Pennsylvania, we'd be fine. But, okay, this is where it gets scary. 1908, there was an asteroid probably about, much less than a mile across, bigger than a football field, that came through Earth's atmosphere and exploded several miles above the Earth. This was a 3 megaton explosion. That's a hydrogen bomb. Okay, it happened right here in Russia, Siberia. This is what it would have looked like from space. And this was from a Soviet expedition about 20 years later. It had knocked down trees in an area about 800 square miles in a butterfly pattern. Now, if this had happened over New York City in 1908, would have killed like 10 million people, okay? So this happened, relatively recent in Earth's history. So that should really scare the heck out of us, and it scares me. I mean, I'm not like taking out a life insurance policy for it, but it's scary. Now, more recently, over Chelyabinsk, a city in Siberia, 2013, this exploded with the force of an atomic bomb. It exploded about 22 miles high in the atmosphere, and it created a blast wave that broke windows and shattered glass and scared the living bejesus out of. This is a city of 1 million people. It's an industrial city near the Ural Mountains. Okay, dog seems unconcerned here. To our knowledge, nobody was killed, but over 1,000 people had to be hospitalized, mostly from injuries from shattered glass. Now, the really good news, I'm glad that happened in 2013 and not 2025. Because once it exploded with the force of an atomic bomb like the Hiroshima atomic bomb, at the time the US and Russia did not have great relations, but they're better than they've been like since the invasion of Ukraine. The Russians did not panic, okay? They did not say, oh, the United States is launching a nuclear attack. So they didn't launch nukes at us, and then we retaliate, and then within an hour you have like 5 billion dead people, okay? That did not happen. If something like this were to happen today, it would be scary. Now, it wouldn't happen because of the US. The Air Force has satellites. We would know immediately that this was a natural event because it would see the asteroid come in, and it's going to come in a different trajectory and a much higher velocity than a ballistic missile coming from Russia. So we would know immediately that this was a natural event. But presumably, we would not retaliate for, like, are we gonna like shoot a nuke at the asteroid belt? But I don't know if the Russians have this capability. I don't know how they would react like right now. So I do find this kind of scary. And I just want to conclude this first part of my talk, and I'm more than halfway through, by the way. So the meteors that we see at night, these are all little bits of asteroids, like sometimes they're not much bigger than a grain of sand, that are entering the atmosphere and burning up in the upper atmosphere. And you can all hold this after my talk, but I brought a piece of a nickel-iron meteorite that's a fragment of a small asteroid that blew up over eastern Siberia in 1947. So I'm going to put this on the table, people can see this after the talk. So I do want to take a brief pause for questions, and I don't mean this at the bottom. I'll take maybe 2 questions, but they have to be questions that pertain to the inner solar system, because yet if you have a question that pertains to the outer solar system, I will get there. So any questions about the inner solar system? Mike?
Do we have photos of the entire surface of Mercury or not? I'm not
Yes,
sure if we do.
but okay, but at different, and you can see that on the globe at different resolution, because Messenger was in an eccentric orbit.
Sure.
So there were times it was taking pictures of Mercury close, and other times it was farther away. So when you look at this globe, you can see it on the globe. There's areas where it's very sharp and detailed, other plates it's fuzzier, and that's because of the different resolutions. But the basic answer to your question is yes, the entire surface of Mercury has been imaged to fairly good resolution, but not equal resolution. Let's see, I saw a question over. Oh, yes.
The myth of Icarus dying from flying too high and being burnt up by the sun, how would that be possible exactly with the sun being so far away?
Yeah, exactly. No, you actually hit it right. It's just a myth. I think it dates back to ancient Greece. And one thing too, the idea is if you get higher and higher up in the atmosphere, it gets warmer because you're getting closer to the sun. It's actually the exact opposite because of the greenhouse effect. Like the hottest places on Earth are at the surface, and the higher you go, like just ask anybody who does mountain climbing, it gets colder and colder because of this greenhouse effect in our atmosphere, and that effect gets weaker and weaker the higher you go. So that just tells us that the ancient Greeks didn't understand, they were very brilliant people in philosophy and literature.
Too much use of them.
That's right. But the thing is, the Greeks never really developed science in a modern form. There were some like Archimedes and other Greek scientists who did make some accurate scientific predictions, but in my view, and different people might not agree, in my view, modern science begins with the great Italian physicist and astronomer named Galilei, around the year 1600. So, for example, people who claim things in the Bible are science, the Bible's not a science book because it was written, 1,000 years before science. And science is not a thing, it's a method. And science doesn't date until around 1600. In my view, it was Galileo who was the first modern scientist who did systematic experiments and then made predictions and then tested his predictions with experiments. To my mind, he's the first true modern scientist, which is why I put him in the top 4. And I'm just giving you an opinion. 4 greatest scientists of all time: Galileo, Newton, Darwin, Einstein. To me, those are, would you agree with that, Lou?
Yes, yes.
To me, those are the 4, and my friend Bob was a high-level amateur astronomer. Those are the 4 greatest scientists who ever lived. I would even argue that maybe Galileo was the greatest because he discovered, I'm about to show you the 4 moons of Jupiter. He discovered them, and he really discovered and kind of spread the scientific method, and that everything we know about the universe today dates back to me, Galileo, in the early 1600s. Yes, Chuck?
Quick question about the Earth's magnetic field. Been reading a lot of articles about it changing polarities.
Yes.
And also the core becoming solid and we're slowly losing it. What are your thoughts?
Okay, that's a great question. Is about the magnetic field of Earth. The Earth's magnetic field does flip polarity. It's not on a regular cycle, but it happens about every 500,000 years. Yeah. What they think happens, and we haven't observed one, and we don't want to observe one, is what happens is the magnetic field temporarily shuts down, and then it turns back on with opposite polarity. Okay, now during that period where it shuts down, the Earth is going to get hit with a lot more, the solar wind, the radiate, cosmic rays from the galaxy. And if we had satellites, if this happens, like this solar wind and the cosmic rays are going to wipe out our satellites, and we're going to get much more power disruptions. So we know that Earth has many, many, countless times survived these magnetic reversals, okay? So it doesn't have, because they're short-lived, they clearly don't have major biological ramifications, but they would have enormous economic, technological, social ramifications. So the Earth's magnetic field, we've had good measurements going back to the 1700s. There were scientists in the 1700s that were, mainly like in England and Europe, were making very good measurements of the magnetic field. And, we can reproduce what they were doing and said they were getting good, accurate measurements. Okay, the magnetic field on Earth has weakened by about 1/3, okay, since the late 1700s. Okay, that is a cause for a long-term concern, okay, in that the Earth's magnetic field, we might be heading toward a reversal, okay, and that would be a really bad thing. I don't think it's imminent. I don't think it's going to be in the lifetime of anybody in this room, okay, but it is something long-term. I would say it is a concern, but once again, when it turns off, it's going to turn back on because it's done so countless times throughout Earth's history. What's that?
You don't have any idea what that means?
They don't really know, and that's the thing, we kind of have to maybe observe it happening, but they can see, for example, on the seafloor of the Atlantic, this is how they discovered plate tectonics. You can see on the seafloor of the rocks, where you have like magnetized rocks, they're opposite polarity, like you have a stripe where it's pointing north, then south, and north, and south. It's got to be pretty quick, okay? I don't know if quick means like, it's not going to be like an hour or a day, but it might be like just a few years, or it might be like 50 years, but we're not talking thousands of years. So it would reverse pretty quickly, but during that period, we lose all our, the satellites would have to be built to be hardened. You would have to like harden electrical transformers, because it would be much easier for them to get blown out by a solar storm. So it would be a really bad thing for our civilization.
Even flying.
Oh, flying. And Lou would know, he's a retired airline pilot. We would have to fly, I don't know, like 10, 20,000 feet.
Lower and towards the equator.
That's right. And so what was your typical, like 30, 35,000 feet, right?
Oh, yeah, even higher. We got called several times to lose altitude and go south.
Okay.
To get away from the pole.
Okay, yeah, okay. And so it would be a major disruption of human society if we had a magnetic reversal. Maybe one more, you got a question, Bob?
Simple question. Does Mercury and Venus have magnetic fields?
If they do, it's very, very weak. And this is actually a question. Venus, close to the sun, okay, why does Venus have such a thick atmosphere? And because it rotates so slowly, if it does have a very weak magnetic field, and they think that's just constant outgassing from the interior, that Venus loses its atmosphere, but it keeps replenishing it, and that Venus's atmosphere consists of like mostly carbon dioxide. So it's carbon and oxygen, which are less, because they're heavier elements, are much harder for the solar wind to strip. The problem with water vapor for Earth and Mars, especially Mars, it's H2O. It gets broken up into hydrogen and oxygen. Well, hydrogen is the lightest element. It's the most easy to strip away. So that's why Venus has been able to hang on to its atmosphere. Partially, it keeps generating an atmosphere, but also its atmosphere is made of heavier it probably once had a lot of water, and that's all gone, that's been stripped away. Okay, I'm gonna move on now to the outer solar. Thank you all for confining your questions to the inner solar system.